Okay, good. Now let's start with the how we can use a pivot table to summarize our data. Okay, if at all you want the data first of all in table format, you can always that is insert a table. Okay, so to insert a table, you can just highlight your data. That is all your data set. Okay, so highlighting we have some shortcuts. You can either highlight like by like a manual way. Okay, also you can just that is click control all. Okay, you can click control all to highlight, and also you can click control then shift, then you can now play with what the down arrow and the right arrow. Like I've selected up to the last value, and then I also need to select now all the columns. So I just click now the right arrow to highlight that is the columns. Okay, so after that now you can go to insert. Okay, let's go to insert. So first of all, you can insert a table if at all you want. So you can try to insert a table and say where the data is that, and my first row is what is the header. Okay, then click OK. You can see we've inserted a table in that in that data. Okay, if you don't want table, it's still okay. Okay, you can just highlight your data. Okay, then go now to insert pivot table. Okay, then if you want it in a new workbook, you will make sure that is it is checked that is as new workbook. Okay, maybe in that format. If you do that, it will open a new sheet. Okay, and you can now do what you can now do the fields. Okay, if you want it maybe on this same worksheet or on the existing worksheet, you can just go choose now. You can now choose existing worksheet. Okay, then after that you will be it will highlight for you to check that is the location. Okay, so maybe I want the data to be or the pivot table to be at this point. So once you highlight, you'll click OK. Okay, so once you click OK, you can see we have this blank template which and you can see a message in it. To build a pivot or to build a report, choose the fields from the what from the pivot tables. Okay, so under the pivot table you can see we have the fields. Okay, the pivot fields, and where we can drag. Like for example, if we want to drag, or if you want to check maybe the highest qualified member, we can drag it to the what to the roles. This is how it will appear. So you can see it has given us a table which has the graduate, that is illiterate, also postgraduate, professional, and undergraduate, all those categories. Okay, when you can also put it under columns, and this is how it will look like. Now it will be on the what on the on the column. Okay, but I love it when I have it in rows. Okay, then after that you can see we have all the fields are complete. Okay, no field which has what no field which has missing value. So I can decide maybe to count it by monthly income by showing count. I can show it by that is monthly expense. I can show it also by the field itself. Okay, you can count the field itself, all right, or count all the other that is the other columns, provided you don't have what you don't have any missing data in those other fields. So I'll just also drag the same field to values. Okay, once I drag it to value, you can see now we are getting, if maybe you had done this, you can now count, you can cross confirm if you got 19 of these members, or of these entries. Okay, we have 19 of the entries are categorized as what? Graduates. Also, 5 categorized under illiterate, 6 categorized under postgraduate, 10 categorized under professional, and 10 under that is undergraduate. Okay, so you can see now we have this count. All right, now in case maybe you want like we also have other fields. Okay, we also have other fields whereby you can do a sum, you can do an average. Okay, you can do maximum, you can do minimum, you can do product, all that. Okay, and also you can format the that is the data according to your preference. Okay, yes, so for my case I'll just continue with the count because I wanted count. Okay, are we together up to that point? Are we all together?
Yes.
Yes.
Okay, good. What if maybe I want to present this data in percentage form? Like, I want to, if I'm reporting, I can say 15% of the that is of the entries, okay, were under graduate, that is category. 3% were illiterate, and 10% maybe they were undergraduate. Okay, so to do that, you can also format your field. Okay, by right clicking any value, you can just, provided it's this value, don't click right click at this point, just highlight where we have the values. Okay, then once you right click, you will see show values as. Okay, you can see show values as. Okay, maybe percentage of the grand total, so that the total of all these percentages total to what? To 100. Okay, so with that we can see that 8% that is of the that is of these people, okay, were graduates, 10% were illiterate, meaning they've never gone to school. 12% were postgraduates. Then professionals were 20%, and undergraduates were what? Also 20%. Okay, that's how you can do. Or you can now change it back to no calculation, meaning it will just give you the count. Okay, yes, that's how we can use pivot table to what? To his that is this thing. Okay, yes, so you can always change, you can always change. Even we can try and check maybe the average salary, the average salary or the average salary. You can see this is the average salary for the undergraduates. This is, sorry, sum of, this is the sum of the salary for, or that is for all graduates in this category, under that category. Then we also have this amount is the sum of that is the salary, okay, for all what? For all illiterate people. Okay, we can also try and sum their what? Their expenses. Okay, so you can see professionals, their expenses are 50%. They are that is 50% of their salary, or 50% of their income is going to what? Is going um, to pay their expenses. Okay, yes, now maybe if you don't want the sum, you can also change this to what? You can also change this to average. How do you change to average? You will now come here. Let's start with the income. Come here, then go to value fields, then you will choose average instead. Okay, once you change it to average, you can see it has changed to average, and even here you have average. The same to the second. Okay, the same to the second one, you can change it to average, and you can see we have the average expense, okay, per each category, and also average income. So that's how you can play with what? With the pivot table. Pivot tables are very important, more so when you are building a dashboard. Okay, when you are building a dashboard for your analysis, like to automate your processes. Okay, if you want to automate your processes so that in case maybe you collect other data, you can just paste here, then click refresh, and everything on your dashboard updates itself. Okay, yeah, that is mostly for repetitive tasks. Okay, good, nice. So that was the pivot table part. Guys, you are satisfied with that?
Yes.
You are all good? Also, apart from Susan, Susan is good. What about the others? Maybe, yeah. What about the others? Just by a show of thumbs. Okay, good. Nice. Thank you. All right. Now let's go to the next thing. Okay. So I only need, let's assume I need this column. Okay. And I need these other two columns. Or I can just decide I need what? This column and this column. Okay. So like I want to model, like to see that is the variance between the income and what? The expense. Okay. The variance between the income and expense, so that I can see if we have that much, that is big variance. Okay. And also standard deviation. So I'll just copy these two columns. Okay. Then I will paste them in a new worksheet. Okay. So that now we can start mathematical, that is computations. Okay. All right. In this case, let's assume we were to model, okay? We were to model something, like to predict something. Is it possible for you to predict your income out of your expense, or it is possible to predict your expense out of your income? Someone? That is a question to that is to the class. Is it possible to predict income given expenses, maybe the expenses, or it is possible to predict expenses, okay, out of maybe your income? There is a point which I want to drive. Yes, David?
I think you can predict expenses from the income.
Okay, why? Why?
Yes, because maybe when you know how much someone earn in a month, you can predict how normally we know how the primary needs of someone. So maybe the other issues can be you can assume the first needs that will consume the salary of someone. So you can predict the expense.
Okay, yes, that's very correct. Even from the logic, okay? you know that your salary determines your expense. If you get maybe a small income, then definitely your expense will be what? Will be also small, unless maybe you have other source of income. But here we are talking about like all the income, or if you have one income, or if you have two income source of incomes, or the aggregate. Okay, remember, your income determines your expense. Okay, that's why, like, someone with a small income will spend will spend less. Okay, person with high income will tend to also spend more. Okay, and if you want to prove to have a proof, just check on yourself. When, let's assume that is 10 years, or let's say 3 years ago. Okay, you were you were receiving, let's say, 50,000. Okay, so in that period you were spending, let's say, 20,000 or 30,000. Okay, now let's assume your income has increased to 80, meaning your expense also will increase to what? To 80. Maybe if that time you were living in a bed sitter, you might not decide to maybe move to one bedroom or two bedroom. Okay, why? Because you have the money. Maybe you can also when you were living maybe in bed sitter, you were not you didn't have maybe more that is electronics, that is many electronics, like, because you had a what? A small that is amount of income. Okay, so you, let's assume you did not have a fridge, you did not have a home theater. Okay, then once you start getting 80,000, now you see the need of what? Of buying a refrigerator, of buying uh, that is home theater. So definitely you can see that will increase your expense, even if it will be a one time. Now the expense in terms of electric bills, okay, electricity bills, okay, will also increase. All right. Yes, so that's the idea behind it. Now, it's true, we can use now our income to predict what? To predict that is to predict our expense. Why? Because our expenses that is depend on what? Depend on the amount of income we are getting. Okay, so in that case, now we will have what? We will have x, that is our income, as our that is our x variable, and we have our expense as what? As our y variable. Okay, it's like this person, you can see this person was living beyond his income. Okay, so meaning this person had a lot of debts. Why? Because his income, let's assume this is the only income source, is getting 5,000, but his expenses are what? Are that is are more than his income. Okay, even for this person. But now for the others, you'll find that is the and also this person is expending more, but it's only few what? Few cases. Okay, it's only few cases. Like, for example, if I just do this minus this, so that I can see where we have the negatives. Where we have negatives, then meaning that person is spending more than what is earning. So you'll see it's only this person. Okay, also this people, and also this. Okay, only few, 5 people out of account of that is 150. sorry, of 50. Okay, so good. That's how now you can logically determine what? Determine your x variable and your y variable. Okay, that was a lesson by the way. That question, that explanation was a lesson itself. How you can identify what? Your independent variable and independent variable. But we'll discuss much when now we will be dealing with what? When we'll be dealing with the, or in our next topic, that is linear regression. Okay, good. Now, remember what we said about, that is it, it was what? Variance. Okay, let's assume we have, that is x1, okay, x2, x3, okay, x4 up to xn, okay, minus 1. All right, so now we need what? We'll need variance and standard deviation. Variance and standard deviation for what? For each two, that is for each two. Like, we'll find the standard deviation for x, and also variance and standard deviation for income, and also standard variance and standard deviation for the what? For the expenses. Okay, so the formula, remember, I was just illustrating the formula. Remember the formula for variance, and since this is sample data, we are dealing with sample data. Okay, here we are dealing with the sample data. We know that sample data, that is sample variance, which is s squared, is given by summation of xi's, okay, minus x bar, okay, squared, divided by what? n minus 1, because this is what? This is sample data. Okay, if it's sample data, we have to use now n-1. Okay, if it's population, we'll now say it is summation of xi's, okay, minus mu, because remember, in population, mean is referred to mu squared, okay, divide by what? N. Okay, sometimes people can decide maybe to factor out, that is 1 divided by n minus what? n-1. So we can say we have 1 divided by n-1, okay, multiply by summation of xi's minus x bar squared. Okay, you please, we can try to confirm that so that I might not be wrong. So that is the sample variance formula. Sample variance formula. Yes, very correct. Very correct. So basically, we know that then this is variance, okay, s squared. Then our standard deviation will be now s. We won't square, okay, it will be s only. Okay, so it will be s is equals to square root of 1 divided by n-1 multiplied by summation of xi's minus x bar squared. Remember, x bar, it's what? It's mean. Okay, we have the xi's. These are the xi's. You can see these values, they are our xi's. Okay, so we have xi's up to 50. Okay, then we have that is the mean. X bar is the mean, that is the symbol average. This is the average. And then we have n is now the count. Okay, of our entries. Okay, and then we have our data ready. Okay, we have everything. So for us, what we'll need now, it's what? It's to compute that is the mean. Okay, so what I will do, I will remove this. I will do for xi's, and for that is for income, and for you guys I want now to do the same, now using what? Expenses. Okay, yes, like you can do for expense just to practice, but in this class let's now go with what? With the income. So we'll need the mean of the income. So let me say here we have the mean of the that is of the income. Okay, so we have the mean here, and then we can now compute the other things. Okay, so after the mean we will need what? After the mean, as per our formula, we will need xi's minus what? X bar, because X bar is the mean. So after that we will now calculate what we call maybe the xi's. Let me just include that. That is the xi's. Okay, minus X bar. Let me just call it X bar. Okay, then after that we will have X bar squared. Okay, this is raised to raise was this, raised to 2, that is squared. Okay, so with that now we can now compute that. So it will be equal to that is let's first start with the mean. The mean is our X bar, remember that mean is our X bar, that is this is our X bar. Okay, so it will be equal to average. Remember we talked about mean is the simple average. Okay, so it is average of what? Of this range. So you will highlight this range. Okay, then you can now close. Okay, so this is our mean. Right, so we'll be taking these values, minusing what? Minusing this, to first of all do this. So what we'll do, we'll say equal to this value, it's varying, minus this value. Okay, but now since we are referencing to only this cell, we'll have to lock or reference this cell. Okay, so with that you will lock E1. Okay, you will lock E1 with the dollar signs. Okay, to reference. So after that, now we will do what? We'll drag down. Okay, you can just autofill, that is by you can just come here and just double click. Let me just clear this first. Okay, so if you want, you can just come here at the end, then double click. Once you double click, you will autofill. Okay, yes, so you'll get all these values. And then now we need the what? The x what? The x i's minus X bar squared. Okay, so you'll just say this equal to this, that is xi minus X bar squared, then raised to what? Raised to 2. Okay, then just enter, and then you can do what? You can autofill. Okay, you can autofill after you've squared this. What have you done? You have squared the difference between the xi's and the X bar. Okay, now what what are we lacking? We are lacking, we need n, and also now we need n minus what? Minus 1, which will be used. So n, remember we said, is just the count, okay, of all our entries. Okay, so we'll just count our entries, and then we will need now n minus 1. So n minus 1 will be our n, then minus 1. So with that we know our n minus 1 is what? Our n minus 1 is 49. Okay, good. Now we will need to calculate what? The variance. So what to calculate the variance, remember we said it's summation of x i's minus x bars squared divided by n minus 1. So we are going to sum all these values to get the summation of x i's minus x bars squared and then divide by this value. Okay, so to do so I can just compute here, say what is the variance. The variance, okay, the variance will be equal to sum, okay, of all these numerator data, okay, that way, and then divide by what? We are dividing by n minus what? N minus 1, and n minus 1 is this value, which is 49. Okay, so with that we'll get this variance. You can check if you'll get this variance. Okay, just allow me to just counter check if it is the true thing. Yes, we are getting the same value. So this is the correct value. Okay, nice. Before we can explain the value, what the value is, so prepare to tell me that is the conclusion, or what information are you getting from this value. This is just a value. Okay, this is just a value. So we've used mathematical method to calculate what? Variance. Okay, we've used mathematical method to calculate what? Variance. What about now that is the variance using the inbuilt Excel function. Okay, the inbuilt Excel function. So with that you will say equal to variance. Okay, just write var, and under variance you can see we have var.p and var.s. Okay, so var.p, it calculates, that is variance for entire population. Then variance.s calculates the variance for what? For a sample data. For our case we are using a sample data. Okay, so you'll use that is var dot what dot s. So it will be, that is, you'll use that and then select the data. Okay, you can now just select the data which you want to find the variance. So just highlight the data for variance and then done. Just click enter and you will have calculated, that is the variance now using Excel inbuilt function. And you can see we are getting the same value, meaning our working process here was what? Was correct. Okay, let's go to standard deviation. So remember we said that for standard now deviation, it is that is square root of what? It is square root of variance. So in this case we'll say equal to square root sqrt, okay, square root of variance. Okay, so once we calculate that, you can see we are getting this variance, and this variance is still what? Is still I, meaning we, okay, I don't want to talk about the information. I want you to give me, that is the information which you are getting here. I was almost to tell you that to tell you the answer. Okay, all right, then we can also try to use the inbuilt Excel function to calculate what? To calculate the standard deviation. So to do so, you will say equal to standard deviation, that is STDev. Okay, STDev. So under STDev we have STDev.p, STDev.s. So for STDev.s, it basically gives us that is the standard deviation for the what? For our sample data. Okay, so with that I'll just use now STDev.s for variance. Then I will highlight what? I will highlight that is my data set, and then enter. You can see we are also getting the same value as the same when taking the square root of what? Of variance. You can see this. Now we have what? We have these two values. Okay. Now, what does these two values mean? What do that is this value for variance and this value for standard deviation mean? Because here I can just see numbers. Yes, David?
Yes, I I didn't see how you put on formula for the standard deviation.
Okay,
Not the inbuilt in Excel inbuilt formula.
okay, I can repeat that, no problem. Okay, so with that, you'll just say equal to STDev. Okay, you can see we have STDev. We have STDev for that is for population, that is stdev.p, and stdev .s. This is for sample data. So we are using sample data. So we are going to choose the stdev dot what? Dot s. Okay. Then you are told now to insert now the range. Okay. So you will come here and insert the range of what? Of your income data. Okay. From that is the first up to the 50th. Okay. Then after that, after highlighting the range, you can just click enter. Then you will get your standard deviation value. That's okay, David?
Yeah, I said the value above
Oh,
the
this
one.
one.
Yes, yes.
So for this, I basically took that is the square root. Okay. That is because we know variance is what? Variance is the sorry, the standard deviation is the square root of what? Of variance. Okay. So what I did, I just said equal to square root. Okay. SQTR for square root. Okay. We have square root of this value, which is variance. Okay. And then that's how I got the value.
Good. Thank you.
All right. Now I want you to explain to me what is these values? What are these values? What is this? What is this? What is this? What is this? What is variance? What does this variance value mean? Does this standard deviation value mean? Fred? Frederick? Frederick, what does those values mean? Don't be shy off. It's from the definition we made about variance. What is variance? What does variance show? Or what does that value indicate? Steve K?
I would say uh, because the figures are quite huge or large, it means that the that most of the figures vary or spread quite high from the mean.
Like we have, okay, we have that is a large distance between the what? Between that is the range of each value to the mean.
To the mean, yes.
Basically, like the data is highly spread out, okay, away from the mean. Okay, anyone else with a different? indication in terms of now income. How can we explain that? Like these people, their income tells us that, okay, most of the people earn less or more. Anyway, can someone maybe try before I can conclude? Wangui?
Please repeat the question again. Sorry for that.
Like I just need, if we have the variance here, we have this value and this
Mhm.
value. What does this value indicate when it comes now to this income data?
So variance basically measures the spread about the mean. So I would say that the average observation is that far away from the mean, which our mean was 41,558.
So we can say most of the people are earning much less and also much low compared to the average income.
Exactly. And then for the standard deviation, because it's so far away from zero, it
Uh-huh.
means that our data or observations are not are heterogeneous, meaning
Yes,
that the
that's
outliers
the
are
word.
many.
Yes,
Yeah.
that's the word. Hetero, like it shows heterogeneous. When we'll be dealing with the regression, we'll talk about heterostech something. We have a very homoskedasticity, heteroskedasticity. It's a very huge term, basically to show like the spread, okay, of the data. Like for example, let me try just but that will talk when we are talking about or homoskedasticity. We'll basically talk about that is dispersion of our data. How our data is what is dispersed. Okay, how our data is dispersed. Okay, good. Now let's continue. That's okay. So basically, when we see that is the variance, it's a big value. So it means we have a very huge variance in people's income. Okay, like we are having people who are that is earning much less than the average salary for all these people, and also we'll have some people who are quite earning that is high, okay, that is high income, okay, in comparison to what, comparison to the others. Okay, all right, good. Now I want us to move to what we call covariance and correlation. Covariance and correlation. Okay, covariance and correlation. So remember here under covariance and correlation, we talked about this formula. Don't let me see if I can remember it. We said that that is covariance of x and y is given by that is summation of now x i's minus x bar not squared multiply by that is yi, okay, yi minus y bar, okay, divide by, I guess it was n minus 1, n minus 1. So that now the correlation can be now the covariance of x and y, okay, divide by what? Divide by that is standard deviation for x, okay, multiply by standard deviation for y, sorry. So in this case we can say SS if we are talking about sample data. Okay, let's just confirm the formula for covariance. So covariance variance formula for sample data, for sample data. So you can see, where is it? For sample, you can see. Now you can see for sample, we are taking n minus 1. Okay. But for population, we'll only take n. Just ignore the capital N here. Okay. It's almost the same thing. Okay. All right. So basically now that's what we need. So we can now do the mathematical way, and also do the using the Excel inbuilt function. So we'll need, that is for column for xi minus x bar, and also another column for yi minus y bar, and also we'll need x bar value, and we'll need y bar value. So let's do that. So in this case, we are saying that, let me just insert a column here. So we need mean for x, okay, and also we need mean for y, okay, and then we need what? N minus what? 1. Okay, so for n minus 1, we know it's equal to count of these, okay, you close the bracket, then you can minus 1 just to finish it. We had gotten 49 SMS here. Okay, just depends with how maybe you are good with maybe formulas to simplify, that is your work. So with that, we'll need now the average for, remember we said this is our x and this is what? Our y. So with that, we'll say equal to average. Okay, just keep an eye here because we've done this. Okay, so it will be average, then for x you'll take the range for all this data. Okay, then click enter, you'll get the average, okay, for x, and then we also need average for y, so it will be average for y. Then you will highlight now the expense data, since it's our y. Then we have, this is the average for y. Okay, then after that we need what? X i's minus x bar. Okay, and also we need what? Y i's minus y bar. These are two formulas which we need. Okay, so I'll also add this. Okay, good. Now we can compute this. We have x bar and we have y bar. Let me just highlight it in green. So we need these two, that is value. So what we'll do, we'll say equal to x bar, sorry, x i's minus x bar. And since these we will have to reference this so that it might cut across all the other values. So we'll just use $sign to lock that. Okay, and then you can just autofill. Okay, then we can also calculate the y i's minus y bar. So our yi will be equal to, this is our yi's, these are our yi's, then minus now the y bar. Okay, the Y bar. And since we are also referencing to this cell, we are going to lock it. Okay, then enter, and then you can autofill. Are we together up to that point? By
Yes, we are.
a show of thumbs. Okay, I can see Muhammad Abdallah did not join today. It's okay. Maybe he will follow. Then we already have now xi's and x bar. What now we can do is just to do the we want to take this, multiply by this. Okay, so what we need now is, okay, this multiply by this. Remember in our formula we were remember in our formula we were taking we'll now take this, multiply by this, and then we shall do a summation. Then the summation we divide by what? N minus 1. So in that case we'll say equal to this multiply by this. Okay, these are our values. Then you can drag down. Okay, and then after that now we can calculate what? The summation. Now we can say we need now that is the summation of what? Of this. We need the summation of this, so it will be equal to sum. We'll just use sum function to sum all these values. Okay, so in that case we have a summation here. Okay, now it's our time. We do now the correlation, sorry, the covariance, the covariance. Okay, so covariance, now our covariance will be our summation divided by n minus 1, and this is our value. This is our covariance value. Remember we said that covariance runs between negative infinity to infinity. That's why you can see we have a covariance of what value? We have a covariance of 204 m, 204 million. Okay, that's our covariance value. Okay, then that's how we do it mathematically. What about maybe doing the covariance for that is using Excel inbuilt functions? Okay, so covariance using Excel inbuilt function, for us now to know if our calculation were correct. Okay, this is how we can know. So we'll say equal to cov. You can see now under covariance we have covariance.p, this is for population, and we have covariance.s, that is for sample data. Remember we are using this as what? We are using this as that is as our sample data. Okay, all right, so we'll use covariance dot that is dot s, that is for sample data. And you can see now here it needs us to insert array 1 and array 2. Array basically shows us it's like a list of values. Okay, so our first array will be all the monthly income values, and the second array will be all that is monthly expense. So we are going to start with the first array. So we are going to highlight the data. Okay, We are going to highlight the data for what? For income. Then after that, you can see the two arrays are separated by a comma. So we'll say comma, okay? Then select the second array, okay? Then select the second array. And after that, now you can do what? You can now close your brackets and then run. Wow, you can see this is the same value. We are getting the same value. All right, we are getting the same value. Then my question, what does this value mean? What does this value mean? Can I hear from you guys? Ahmed, Noor, what does this value mean? From the way we termed covariance.
I'm still trying to digest.
Okay. Susan?
It shows, okay, I think it's a positive value first, but I don't know if that applies only to correlation, but it shows that
it also qualifies for covariance, because how do you differentiate between positive covariance and negative covariance?
so it shows a positive relation between the monthly household income and the monthly household expenses of that magnitude.
So not really. If you had of that magnitude, you will be wrong. So what
Oh,
basically, yes, you'll be wrong. Because remember we said covariance shows us direction. It's more of, it measures directional, or it has that is, it is more of directional, okay? Like it shows us the direction to which maybe these values are what? Are moving. Okay, these two variables are moving. So basically what we can conclude here is, okay, you can see this, it's a positive covariance, meaning they are, that is, income and expense are directly proportional. Okay, what do I mean by the term directly proportional? Basically it means that when the income is increasing, so does the what? So does the expense. Okay, if we increase our income, definitely our expenditure will also increase. That's what it tells us. Like the two variables are moving into one direction. So increase that is, increase in one variable will trigger an increase in the other variable. The same as decrease in one variable, it will trigger a decrease in what? On the other variable. What if it was negative? Then we could say as one is increasing, the other one is what? Decreasing. Okay? As one variable is increasing, the other variable is decreasing. So in that case, they will be inverse proportional. Okay? Yes. So basically that's what covariance tells us. So from this case, we can conclude that from the covariance value which we've gotten, it shows that and any increase, okay, any increase in income, it will trigger an increase in also what? In also in expenditure. Okay. All right. Are we together up to that point? Together, David and the others, Noor, we are good. Noor, yes, okay. All right. Now let's go to correlation. Okay. So remember correlation, we say that it is covariance divided by what? By standard deviation. That is product of the sum of standard deviation of the two variables. Okay, so basically what we are going to do here is we already have the covariance. Okay, so what we need is the standard deviation for income and standard deviation for that is expense. Okay, so in that we'll need STDev for income. Okay, and also we need a standard STDev for that is for our expense. Okay, so in that case we'll just use Excel inbuilt function here to calculate. So we need STDev. It's for sample data, and then this is for income, so we are going to highlight the range for income. Okay, then it will calculate. Then for expense it will be STDev dot s, that is sample data, but now for expense. Okay, so these are the what standard deviation which we've gotten. Okay, so we need the product of the STDevs. Okay, so it will be equal to this multiplied by this. So this is our what product of our standard deviation. So for our correlation we'll say it is equal to covariance. Let's use any covariance divided by product of sum of deviations, and you can see we are getting what we are getting this value as our correlation. So remember we said that for correlation it runs between -1 to +1. So in case you get any value which is is greater than 1, okay, and smaller than -1, then it will be what? Then it will be wrong. Okay. Yes. So this is our what? Our correlation value. Then we can try also check the correlation value. Okay. Correlation value. That is correlation value for that is the correlation value using Excel inbuilt function. Okay, Excel inbuilt function. So in that case we'll say equal to, all right, core. So core, it doesn't have either it's for population or for sample. Correlation is correlation. Okay, it doesn't matter if the data is sample or population. Okay, so with that case we'll use correl, meaning it's correlation. You can see it returns the correlation coefficient between two data sets. Okay, so we need the correl. Then for that now we can what? We can now highlight the two arrays. So you have array 1 and array 2. So for array 1 we are going to select the income range. Okay, then for the second array we are going to select the expense, and then just run, click okay, and enter. So you can see we are having the same what? We are having the same values. Basically, what does this show us? What does this show us? What does that show us? Yes, David?
It shows that the the income and the expense has a fair positive relationship.
Yes, fair. I was looking for the term fair. It has a fair positive relationship. Why have we said fair? Because you can see it has not reached that is the point of terming it as strong or perfect. Because we said we'll usually consider a correlation to be strong for any value which is greater than 0.8. Okay, so if it was greater than 0.8, okay, we can say that is what? A very strong correlation. Okay, if it was 1, positive 1, we could say that is a perfect positive correlation. Okay, but for 0.649, we can say it is relatively fair correlation. Okay, meaning that we have, that is like we have a relationship. Okay, we have a positive relationship between what? Between these two variables, like that is the change in expenses. Okay, or the change in income, sorry, the change in income can explain about the change in expenses by like, let's say 64%. It can explain like 64% change in what? Change in that is expenditure, given what? Given a change in what? In the income. Okay. Yes, that's what basically correlation and covariance mean, and that's how we compute. Okay, I want you to give me only that is only 5 minutes, so that now we can conclude. I want to show you that is a easier method, okay, of doing so. Okay, rather than using all those formulas or using all those processes. Okay, like a easier one, that is a easier method which you can do what? You can return the same data. Okay, all right, good. How many of you have ever worked with this tool, the data analysis tool? Can you go to data and check if you have this tool, this feature, data analysis? How many have that tool? Go to data, and then at the end here, okay, at the far right, check if you have this tool. If you don't have, don't worry, we can add it. Anyone? If you have it on your side, okay, yes, Wangoi has it.
Oh,
Yes.
sorry. I don't have it. I thought those raising hands were those that do not have it.
Okay, okay. Maybe let's go the other way. Those who have it, can you raise maybe your hand? Those have it. Seems none has. Okay, meaning maybe you've never worked with it. Okay, so with that, I want us now to insert on your side. Go to file, click file. Okay, in your Excel, this tab, file. Okay, we are together. Go to options. Once you click options, it will give you a pop-up window. Okay, it will give you a pop-up window. Okay, then click add ins. Click add ins. Click addings. Then on the addings, you'll see somewhere we have addings here, which we have different addings, but I want you to click go. If you can see go, click go. If you click go, you will see something known as analysis tool pack. Analysis tool pack. Check on analysis tool pack, just check it so that it might be ticked, then click OK. Check it and click OK. Once you are done with that, go to data and see if you will see that data analysis feature. If we are together up to that point, show me thumbs up. If you've successfully done so, Susan, good. Wangui, Otieno, Deborah, Rose, Noor, Frederick, yes. Steve K. What about you, Noor? Yes, Noor. Can see your hand is up. You've managed. All right, cool. Good. Now I just want to show you briefly how to use it. Maybe you can go and study more about it. So what we need to do, you just go to data analysis, click that on data analysis. Okay, so you'll see a lot of analysis tools here. We have ANOVA, we have ANOVA two-factor, we have ANOVA two-factor without replication, we have correlation, we have covariance, we have descriptive statistics. So for our statistical class, we'll discuss about correlation. We'll use correlation, we'll use covariance, we'll use descriptive statistics. We will also use regression. Okay, you can now maybe go and search. This is on that is advanced level. You can also go and see how you can use the other tools. Okay. All right, so I want us to start with descriptive statistics. So for you to get the descriptive statistics, click on descriptive, okay? Make sure you check or highlight the descriptive statistics, then click OK, all right? Click OK. Then after clicking OK, you can highlight your data, just highlight all that is those two columns, just highlight those two columns. Okay, up to the end. Then since we have the first row is our label, you can say, you can check labels in the first row. So check labels in the first rows. Okay, then we want the output to be on columns. Okay, like on columns, the output to be on columns. Okay, then output options. Okay, so under output option, if you want the output on the same worksheet, you'll just check output, then you'll select the worksheet. Okay, that is the cell which you want to output the values. Okay, if you want to output your values on new sheet, you'll click output on new sheet. If you want to your output to be on new sheet, you'll click, that is on new workbook, you'll click on new workbook. Okay, for my case, I want output to be on the same that is same worksheet. Okay, and then what will do I need? I need the summary statistics. So remember to check summary statistics. Then if you are choosing the output range, okay, make sure you choose inside this uh, table, just click in and then click the cell where you want to output that is your values, then click OK. Once you click OK, you will see now the summary of what? Of your statistics. Summary of your statistics. So in that case, you'll see we have the first two columns are for monthly income, then the second column are for that is monthly expense. So you can see we have mean, we have standard error. We shall discuss about standard error when we'll be discussing regression analysis. You can see we have the median. We also have the mode, the standard deviation, sample variance, kurtosis, and skewness. We'll discuss them, and distributions. Then you'll also get the range. The range, remember, is taking the largest value minus the smallest value. Okay, then we have minimum. Okay, this is the minimum value in your range, and also maximum value, it's the maximum value in your range. And then the sum total of your income, and then the count. Okay, the same applies to the what? To the expense, right? This it's like a summary statistics for summary descriptive statistics for your data set. Okay, let's try also for variance, and then I can leave you try for try for correlation. Okay, so I'll choose now still data analysis, then I will go to covariance, then click OK. You can see now I need what? The input range. So for input range, I'm going to input my data. Okay, and since I have not that is highlighted that is the the row or the titles, I won't check labels in the first row. That is labels are in the first row. Okay, then after that I'll go now to the output. That is, I want my output, and I want my output to be what? In this same sheet. So I'll just click the output there, and then I can do what? I can just click OK. So when I click OK, you'll see I have what? I have what we call covariance matrix. Okay, we have covariance matrix. This is now the covariance matrix. So what if maybe I include that is the title? It's okay, we can still include the title so that it might not give you such outputs like column 1, column 2. Okay, so in that case, we'll go to data analysis, covariance, okay, and then we'll highlight that is our data range. So I will re-highlight my data range and include that is the titles. Then I will check labels in the first row, my output on the same cell, and then click OK. So once I click OK, you can see we have what? We have the covariance matrix. Okay, so the same thing when you do that is correlation, you'll get a correlation matrix. Okay, you'll also get a correlation matrix. All right, I guess that's all. That is for the data analysis toolpack. We'll still continue working on it. Okay.